Hello, good afternoon, CTS265, Section 840 students for the Fall 2016 semester at Anne Arundel Community College. This is the CCNP route course, and this afternoon's video tutorial is going to be on challenge activity number 3 from our Cisco Learning Labs curriculum, where we're going to be taking a look at how to configure and optimize EIGRP for IPv6. Now remember, EIGRP for IPv6 is not EIGRP named mode. So we're still going to be working with a 32-bit version of EIGRP in terms of the metrics, and there will be no address family configuration per se in the EIGRP for IPv6 setup. So let's take a look at our scenario and dive in here. It says, although your company has already tested ripng, your boss wants to set up a pilot deployment for EIGRPv6. The basic addressing is already done. We just need to set up the dynamic routing and optimize the default settings. So all EIGRP routes received on HQ from branches must be summarized, making the solution scalable and appropriate for larger deployments. So branches also need IPv6 internet connectivity through the HQ, which should use the default static route. And so this is telling us right here that we're going to be originating a default route off of the HQ router so that branch 1 and branch 2 receive that information. And we may even be creating a stub for branch 1 and branch 2. We'll have to see how this ultimately plays out. So let's go ahead and pull up our job aids here. And we can see the interfaces. I'm interested in the IP addressing that we have here. So we've got the internet, the branch IPs. All right, so these look to be pretty much in line here. All right, so where do we start? Remember, basic connectivity or addressing has already been established. So let's start in the HQ router. Let's go from user exec to privilege exec. We'll get into global config because we know we're going to be changing something here. So how about a do show IPv6 interface brief? And let's see what we've got. We can validate that these addresses are actually configured. Let's say do show run section EIGRP. All right, so nothing has been set up yet. Let's also say do show run include unicast. And what do you think I'm looking for when I say do show run include unicast? Exactly. I'm looking to see if the global configuration command IPv6 unicast routing has been enabled. Because if it hasn't been enabled, when we go to type in our IPv6 router EIGRP autonomous system number command, what would happen is we would receive an error telling us that we must first enable IPv6 unicast routing. Also note that I can put IPv6 addresses on all my interfaces, and I do not have to have IPv6 unicast routing on for that. So it's not until I go in to configure a dynamic routing protocol like EIGRP or ripng or OSPF v3 that if I don't have IPv6 unicast routing on, then I'm going to get the error. But in terms of the addressing for interfaces and putting IP addresses on there, we can certainly do that without any issues. So let's go ahead. Let's get it set up here. And again, it's calling for EIGRP for IPv6 or EIGRPv6 as it's also commonly referred to. So we're not going to do the named mode just yet. In fact, there is a challenge activity, I believe, on the EIGRP named mode. So we're going to say IPv6 router, and just like we would do for OSPF or for RIP, we're going to go ahead and do it for EIGRP. And we'll just use EIGRP Autonomous System 99. All right, so here we are. And you can see that since we said IPv6 router EIGRP, what command is missing? A command that specifically we use with EIGRP for IPv4 that would show up right there. And we saw when we looked at OSPF v3, both with and without address families, that the network command is no longer there. So I won't be typing in network 2001:db8 whatever slash whatever. We don't do that with IPv6 prefixes and prefix lengths. So what we're going to be doing here is we'll set up some general settings, and let me say do show IPv6 interface brief. Okay, so do show IP interface brief. And so now what do you think I'm looking for here? So I looked at the IPv6 information, and now I'm looking at the IPv4 information. Why would I be examining the IPv4 information if I'm getting ready to configure EIGRPv6? Exactly. I have to have a router ID. And so if there's no if there's no IPv4 address, and I'll clarify this here, I'm looking for the address not because the router ID is an IP address, but I'm looking for an IPv4 address because that will be the value that EIGRP for IPv6 selects. If I don't have it specifically, explicitly configured here, it's going to first look to see, is there a IPv4 loopback address that is in the up state that has an IPv4 address on it. And it will take that IPv4 address, but it doesn't use it as an address. It doesn't use it as an IPv4 address. It takes the IPv4 address, and we use it as an EIGRP router ID using whatever the 32-bit value of that 32-bit dotted decimal notation value would be, right? And so again, let me repeat that. We don't use this as an IP address. It's being used as the router ID. We simply take one of the loopback interfaces or one of the physical interface IPv4 addresses, and that is the value that represents our router ID. So there is no IPv4 address here, so we're going to say EIGRP router ID, and for HQ, whoops, we'll simply use 1.1.1.1. All right, so now do show IP, sorry about that, we just did that above us here. So we've got Ethernet 00, 01, and 02. And if I come back to my diagram here, would I be running EIGRP on Ethernet 00? What do you think? No, absolutely not. If this is my transit link out to the internet, I certainly wouldn't be running EIGRP with the service provider. Chances are you'd be either doing a static route, or if you were dual or multi-homed to dual providers where you needed to control the inbound or influence the inbound and control the outbound routing information, you would be using BGP. And we'll be getting to BGP here in about 2 more weeks. So again, clearly I'm going to be doing EIGRP on the Ethernet 01, and I'm also going to be doing it on the Ethernet 02 interfaces. So let's go ahead and let's dive in there. Remember, there is no network command here. So let me go ahead and jump into interface Ethernet 00, where we're going to say IPv6 EIGRP 99. Interface Ethernet 01 IPv6 EIGRP 99. And so now I've started the process. So do show IPv6 EIGRP interfaces, and you can see that these are the 2 interfaces on which I'm running EIGRP. Do show run section EIGRP, and you can clearly see that unlike named mode, we sort of have the configuration all over the place. Okay, so let me go ahead, and we're set up here on HQ, at least to establish the peerings. Let me check on the branch 1 router. Let's see what we've got going on over here. So let's go from user exec to privilege exec into global config, do show run section EIGRP. So again, no EIGRP. Do show IPv6 interface brief. All right, fantastic. So we've got 2 loopback addresses and the single Ethernet 00 WAN connection that brings us back into the HQ router. If we were to, let's see, so we've got that. So let's go ahead and jump in. We're going to say IPv6 router EIGRP 99. We're going to set our EIGRP router ID, and let me see, do show IP interface brief. All right, any IPv4 interfaces in the up state with IPs? No, right? And the reason we see those loopbacks is because they have IPv6 addresses right? But no IPv4 addresses. So we're going to go ahead and say EIGRP router ID, and since this is the branch, the first branch, we'll just say 2.2.2.2. All right, again, no network command on the branch router. So this leaves us with a couple of options, or I should say with one option, is we've got to get underneath the interfaces here. We're going to say interface Ethernet 00, and this, as soon as we say IPv6 EIGRP 99, there we go, we should see an adjacency form, and absolutely fantastic, right? So we've got our adjacency up. Now we want to advertise those loopback addresses. So let's say interface loopback 0, and I can simply recall the previous command, and then we're going to say interface loopback 1, and I'm going to recall that command. But here's also what I'm going to do. So, and I should have done this before. We're going to say IPv6 router EIGRP 99, and I'm going to say passive interface default, but then no passive Ethernet 00, which will bring back my adjacency, and there you go. So now if I say do show IPv6 EIGRP neighbors, you can see here, and again, the 7 that you see way over here, this is the sequence number, right? And remember, the H column is the first column. It's truncating it here on the second line, kind of making it a little more difficult to handle in terms of viewing. But H is for the handle, and remember, 0 means that this is the first neighbor that branch 1 has established an adjacency with. And in fact, in our use case here, this is going to be the only neighbor that branch 1 establishes an adjacency with. All right, so we've got the adjacency set up. Let's say do show IPv6 interface, not interface brief, sorry, do show IPv6 route EIGRP. And as you can see, we are learning the 2001 DB80 100::/64. If I come back to the HQ router, what am I going to be looking for here? Do show IPv6 route EIGRP. I want to see if those loopback addresses show up. And so there are both of the loopback addresses, right? We've got the 2001 DB8016 and the 2001 DB8017, both /64s, and again, learned over my Ethernet. And when I say my, I'm talking about the HQ router, the Ethernet interface here that I peer with to the branch 1 router. All right, so now let's go ahead and let's drop down here to branch 2, and let's establish our EIGRP peering. And so we'll go from user exec to privilege exec to show run section EIGRP. And again, no EIGRP configuration at all. So they definitely did the bare minimum here. So we're going to go ahead and say do show IP, let's say interface brief for IPv4. So no IPv4 addresses. We know we're going to have to put in a router ID. And in fact, what I'll do is I'll leave the router ID out, and let's see what ends up happening if I try to establish the adjacency. Do show IPv6 interface brief. Let's see our IPv6 information. So we've got 3 loopback addresses. And then we have the Ethernet 00 interface up to the headquarters router. So let's go ahead and make this happen here. So IPv6 router EIGRP 99. All right, and there it is. So what does that tell you? Exactly, that tells me that IPv6 unicast routing has not been enabled. And this also proves and validates my earlier point, is that you can go around and configure IPv6 addresses on your interfaces until you can no longer type, and that will work, right? You don't need to have IPv6 unicast routing enabled in order to assign an IPv6 address to an interface, or configure an IPv6 address on an interface. So we're going to go ahead and say IPv6 unicast routing. Now we can get in to the EIGRP global config section for IPv6. So what if I don't assign the router ID? So let's say passive interface default, no passive interface Ethernet 00. Try to keep it the same here. And let's go ahead, let's jump into Ethernet 00. Whoops, sorry, I keep hitting 9 there. And let's say IPv6 EIGRP 99. All right, so it let us create it, but no adjacency yet. Seems odd. What about a do show IP v6 EIGRP neighbors? And there you have it. So why is it that I'm not able to find any neighbors? And not only just not able to find any neighbors, I can't establish any adjacencies right now. I have no usable router ID, right? So this is the criticality of assigning. If there is no IPv6, IPv4 address assigned to any of the interfaces, loopback or physical, that's in an up state, then I definitely need to come in. Let's get back into IPv6 router EIGRP99, and I need to say EIGRP router ID, and so branch 3, and I probably should have thought of a better numbering scheme, or branch 2, we'll make it 3.3.3.3. All right, so now when I get back into interface Ethernet 00, let's say IPv6 EIGRP99, and now we should see that the adjacency is going to go ahead and establish. So in addition to that, I need to get into loopback 0, and we're going to simply recall that same command, IPv6 EIGRP99 interface loopback 1 and interface loopback 2. All right, so there we go. But do show IPv6 EIGRP neighbors. And the commands for IPv6 are just like they are for IPv4, except instead of saying do show IP EIGRP neighbors, we say do show IPv6. All right, so we've got something going on here. So let's say do show run interface Ethernet 00. So we've got our IPv6 address there, but we are not establishing an adjacency with the HQ router. So let's check the HQ router. Do show run interface Ethernet. I believe it's probably 01. Yeah, and that's probably, let me check here. Let's look at our diagram. Right, so Ethernet 02 here on HQ. Ethernet 00 down here on branch 2. So let's go ahead and say do show run. Let's get a look here. Yeah, and all of those interfaces are in the up status. Let me double check that again. Ethernet 02 is 65::1, and on branch 2 we're 65::2. So what may have happened here, and I'm pretty sure I'm in Ethernet 00. I'm going to shut the interface down. It's possible that when I tried to start that EIGRP process up without the router ID, that I may have done something here to the IOU iOS on Unix, and then we'll say no shut and bring the interface back up, and let's see if this is going to be enough to kickstart the adjacency. And do show run section EIGRP. All right, so we are definitely EIGRP 99. No passive interface Ethernet 00. So that is correct. And still no adjacency. And the router ID of 3.3.3.3. And I didn't use that router ID anywhere else. And let's say do show run. Let me take a look at each interface here. So there are the 3 loopback addresses. And they've got that IPv6 EIGRP 99 command. And so those are good. And that looks like it should be good. Am I missing 2001 DB80 65::1, 2001 DB80 65::2? All right, so we should be, well, let me do this. We're going to go to the extreme here. No router, or no IPv6 router EIGRP 99. And then I'm simply going to recreate it. So IPv6 router EIGRP 99. Passive interface default, no passive interface Ethernet 00, EIGRP router ID, and we'll make it, let's pick a different router ID, 5.5.5.5. Now let's get into interface Ethernet 00, where we should be able to say IPv6 EIGRP 99. And that should form an adjacency 2001:DB8:0 : what did we say? Let me scroll back up here. 65:65:1. All right. I've got connectivity there. So we've got connectivity. Did I not enable? Oh, yeah. I'm sitting here looking at it thinking I'm on the wrong interface. It's Ethernet 02. So if you were screaming at the screen, I apologize. Interface Ethernet 02, and we're going to go ahead and say IPv6, EIGRP 99, and now the adjacency is going to form. All right, so there we go. So it had mentioned doing some summarization. And you'll notice that we're just going to be summarizing the loopback addresses. So on branch 1, if I were to say do show IPv6 interface brief, we're going to be doing summaries for here for these two addresses. So 16::1 and 17::1. And so what would that look like? Well, we know that the first 16 bits in the first hextet are the same, 2001. We know that the next 16 bits in the next hextet are the same, DB8. We know that the quad zeros that follows it, all 16 of those bits match. And then we've got our interesting octet. And again, I'm just putting the bits, number of bits here, trying to keep track of our bits. So we've got 48 bits that match. And then we get to 17 in hexadecimal and 16 in hexadecimal. So the first thing we need to do is remember that we've got that rule of leading zeros. So those hextets are actually, when fully written out, 0, 0, 1, 6, and 7 as hexadecimal. So we know that those 4 bits, keeping in mind that a hex character equals 4 bits, which is why each hextet with 4 hex characters is 16 bits. So we know that these 4 bits are going to match, those 4 bits are going to match, and those 4 bits are going to match. So we get an additional 12 bits that match. So 48 and 12 is going to be 60. So now we're down to that hex position that no longer matches. And so we need to sort that out into binary. So 6 in binary, and remember, hexadecimal characters are 4 bits. So it's going to be 4 binary digits. And 6 would be 0, because remember that value there is 8, and the value of 4, the value of 2, and the value of 1. So 0, 1, 1, 0. And that's what that equals in binary. The number 6 in binary is 0, 1, 1, 0. And then 7 logically follows. We've got 6 and then 7. So we pick up how many more additional bit positions that are going to match? 3. So we add 3 to the already matching 60 bits, and I end up with 63 as my prefix length. So /63. So now I need to kind of put this all back together. So we know it's going to be 2001. I'm starting way over here to the left to give me plenty of runway. 2001 : DB8, and we know this because all of these bit positions already match. DB8 : 0, again using that rule of zeros, shrinking it down to a single 0 here because we're going to do the : later on. So 2001 : DB8 : 0 : now what would the value be? So remember, we're kind of jumbled over here, but what we know is that these 3 bits, which were the last bits that match, would be what in hexadecimal? Exactly. It would be exactly what we had right there, so it would be 6. So we would say 1, 6. Now, it's not 16, right? This is not binary, or I'm sorry, it's not decimal. So it's not 16. It is 1, 6 in hexadecimal. And then we're going to say : /63. So I didn't need to write it all the way over there. All right, so that is going to be our summary over on branch 1. And then we're going to do the same thing on branch 2, but let's go ahead and sort branch 1 out here first. So 2001 DB8 0 : 16 : /63, and let's see if this is going to work for us. So here I am on branch 1, and where do we do the summarization with EIGRP? Remember, with distance vector routing protocols like EIGRP, like RIP, and to a certain extent BGP's path vector, but it does have some characteristics that are very similar to distance vector. Remember that with distance vector routing protocols, I can summarize anywhere for any reason at any time. And that's what makes the distance vector routing protocols highly, highly scalable and very, very flexible. And so it's not like OSPF, which we're talking about right now, where you need to do your summarization either at the autonomous system boundary router, the ASBR, because you're summarizing external information. So information coming from outside of the OSPF domain, or you're doing it at an area border router, which is the boundary between different OSPF areas. And the reason you're limited and your hands are kind of tied in OSPF is that link state database. And the fact that the link state database must be the same throughout an individual area. So I can't simply just jump on to a backbone router and start doing summarization. It's just not going to work. It's not going to work. And that's an OSPF. So in EIGRP, we can do it anywhere. And in EIGRP, we typically do it under the interface, right? So what is the interface? Do show IPv6. And actually, we just did that above. Ethernet 00. So I'm going to say interface Ethernet 00. And instead of IP summary address EIGRP 99, right? And then I do my summary. This is for IPv4. What do you think it should be for EIGRP for IPv6? Exactly, it's the exact same command, IPv6 summary address, EIGRP, except we're saying IPv6. So exact same command, except we're saying IPv6, and we're going to put an IPv6 prefix in here. Whoops, sorry about that. So 2001 colon, whoops, we're all over the place here. 2001 colon, DB8 colon 0 colon 16 colon slash 63, right? So nice and simple. We should get a graceful resync, and there it is. And we should see on the HQ router it's graceful. There we go, pure graceful restart. So now when I say do show IPv6 route EIGRP, I now see a single /63. And what's interesting here on the HQ router is where are my branch 2 prefixes at? Let's take a quick look at branch 2 here. What did I not go into? I'm almost positive I went into the loopback interfaces. Do show run, and let's take a look here. And apparently I did not. So let's go ahead and say interface loopback 0, IPv6 EIGRP 99, interface loopback 1. I could have swore I did this. Interface loopback 2. There we go. So now if we come back to H2, what we're seeing here, do show IPv6 route EIGRP. There we go. So I have my /63 summarization, right? So everything looks good there. And now I have these 3 IPv6 addresses from over on router 2 or branch 2. So let's go ahead and head over to branch 2 where we're going to perform our summarization as well. So do show IPv6 interface brief. And we'll give ourselves some space here. All right, so again, very, very simple. We'll make this one a little quicker. So 30, 31, and 32. So first 16, second 16, the third 16 are all the same. And then 0030, 0031, and 0032. So there is the interesting hexadecimal character inside this hextet. It's where they no longer match. So I've already got 16 times 3, so 48 bits already match, plus 4, 8, 12. So again, this should look very familiar, like we just did one very similar to this. So you can see that we've got an additional 12 bits that are going to match. So right now we're sitting at a /60, but that may change. So we're going to go ahead and convert these hexadecimal characters into binary, and 0 being the gimme, and then 0001, 00, oops, sorry, whoops, caught me. 00, let me just get this totally out of here. 0010. So we're going to do a funky looking line here. Actually, that is probably not the best location for that. So we kind of messed this up here. Let me get rid of that. I'm going to squeeze it in right here. So 2 in hex is equal to 0010. So it no longer matches right there. But we've got all zeros. So for our value, we're simply going to end up with 3 followed by a 0. But it's not 30 because it's hexadecimal. These are not decimal values. So, but let's go back to our 60 bits that match, and then we get 61, 62. So we know it's going to be a /62. So let's get our IP summary here, our IPv6 summary. It's DB8, :0, colon. Now here comes the question. We know that the leading zeros are going to get dropped, so I just put a dash there, and then there's a 3. We know that the 3 is here because that all matched up. But then what is our value here? We know that it is 0 because none of those bit positions were on. So 30 : /62. So that's our summary for these 3 IP addresses here. Now remember, as a side note, a little trick or a little shortcut is if I take the number 2 and raise it to the number of bits to the right of where everything stopped matching, and raise it 2 to the 2, this is actually telling me how many networks that summary is representing, right? Because out of those bit positions, we had 0, 0, 0, 1, 1, 0. What's the last bit position? Or I should say, what's the last possible value here with 2 bits? Exactly, 1, 1. So had we had 33, right, it would represent all of them. But we're basically pretending, right, with this summary, I'm representing that, yeah, hey, I know how to get to the 2001 DB8 0 33 : /64, when in fact I do not. I don't have that configured. All right, so keep that in mind, and let's go ahead and let's apply our summary here. And let me pull up. I think it's interface Ethernet 00, isn't it? And it is. All right, so let's get into interface Ethernet 00, where we're going to say IPv6 summary address EIGRP 99 2001 DB8 :0 :30 /62. We get a graceful resync. We roll over here to the HQ router, where we're now going to say do show IPv6 route EIGRP. And now we have optimized the routing table. We've also optimized the updates, right? Because now we have fewer updates that we're receiving. We're going to be receiving the same number of updates, or I should say we're going to be receiving the same number of updates with just different information, right? And so in terms of the query domain, right, that's really the goal here, is we're trying to limit the size of the query domain. But if I come over to branch 1 and I say do show IPv6 EIGRP, or I'm sorry, IPv6 route EIGRP, right, you can see that we have 4 entries here, and one entry we need to pay special attention to is the entry via null 0. And remember, I'm on branch 1 here, and branch 1 is advertising 2 networks, but I think both networks, that these are the only 2 networks that are in the summary. When we talk about branch 3, remember, or I should say branch 2. When we talk about branch 2, remember, there was that :33 : /64, that this falls within the range of the summary we created. However, this network is not configured. So when traffic shows up to branch 2 looking for that network, or I should say destined for that network, it will get sent to null 0. And that is exactly what the null 0 entry is for. It is your safety net. It's your backstop to ensure that you don't end up with loops in your environment. And again, it's because branch 2 is saying, yeah, come to me to get to the :33::/64, when in fact the :33 network, it doesn't exist on branch 2. And so if branch 2 had a default route pointing back to the HQ router, and we did not have an invention like null 0, the packet would go from HQ down to branch 2, because again, branch 2 is saying, yeah, I can get you there. That packet shows up down here at branch 2. Branch 2 doesn't have a more specific match, but it does have a default that says go back up to HQ. So the packet comes back up to HQ. HQ says, yep, I have a routing table entry. You gave me a summary saying you know how to get there. And then down it comes. And then branch 2 says, nope, I don't have the :33 network. Back up to HQ, my default route. And this will go on until we reach max hops, which I believe the default is 100 in EIGRP. And let me say do show, I actually want to make sure about that. I think it's 100. But again, you don't want packets do show IPv6 protocols. I think this is where we see it. Or max hop count, there it is. Yeah, max hop count is 100, right? So we want to make sure that that doesn't happen, and that's what that null 0 entry is for. So let me actually go back to our scenario. I want to look here real quickly and make sure we did everything. I believe we are going to need to, we did the summary. Internet default static route. Okay, so that's probably going to be it. Will be the default static route. So if I come up to the HQ router, remember that there's a couple of ways I can do this. Now it's specifically saying default static route, which means I'm going to redistribute that default static route into EIGRP. Now the other thing that I could do is I could actually go into the interface on HQ, the interfaces that are facing the branch routers, and simply do a summary to quad zeros. So let's go ahead and say, and we'll do that default static route, but let's go ahead and say IPv6, let me back out here, IPv6 route, so we're just going to do the default static route, so :/0, get the slash there. So ://0, and we're going to go out to the internet, which is, and this is probably going to require me to get the job aid up. Let's see, the internet is 100::2. All right, so back to HQ, where we're going to say IPv6 route ://0 2001:db8:0:100::2. And again, that is a static IPv6 route on HQ that ensures that if HQ receives any traffic that it does not have a longer, more specific match for, it's going to simply ship that traffic out to the internet. And then let's go ahead and get into IPv6 router, EIGRP 99. And this is where I would say redistribute static. Now, I could do a route map, which is probably a good idea. If I had other static routes, I would want to do a route map. And keep this in mind as we transition next week into doing layer 3 traffic engineering by using distribute lists and prefix lists and route maps and things of those nature. So, because when I say redistribute static and I hit enter, if I had 25, 30 static routes defined for a whole bunch of other stuff that I don't want to go out into this advertisement via EIGRP, it's too late. I've just advertised those routes. So you would want to do a route map. All right, so now if I come down to branch 1, and let's see what branch 1 has. So do show IPv6 route EIGRP. So you can see that I'm picking up that default static route. Now you can see it also shows EX for external EIGRP with an administrative distance of 170. And I'm also still seeing these 4 different prefixes. And again, the 2 summaries and then 2 /64s. Well, let's do this. Let's spice it up a little bit here. What if I were to have gone under the interface? I'm going to leave that static in there, the redistributed static in there. So interface Ethernet 0, 1, and let me double check that. Yeah, 0, 1, and 0, 2. So Ethernet interface 0, 1, what if I were to have said IPv6 summary address : /0, and sorry about that, I need my EIGRP99 in there, : /0, and hit enter. You can see we get a graceful resync. Let's come over to router 1 now, where before we can see here router 1 had that external EIGRP default, and then it had the 4 more specific matches. So now what do you see? The 4 specific matches have gone away, but yet we still have that external EIGRP default route. And so you can see here that all we have is the summary that's pointing to null 0. And that summary pointing to null 0 has to stay here because I'm advertising that I know how to get to more than a single prefix, right? But it's interesting that you see this, right? That we've got the redistributed static that stays in there as opposed to the summary. So let me go ahead, let's pull the summary out, or I'm sorry, not the summary out, let's pull the redistribute statement out. So IPv6 router EIGRP99, and we're going to say no redistribute static. We should get a graceful resync. Or actually, we've got the other static, I apologize. We have the other static that's still there. So now what do we see? We don't see the summary, right? All we see is this entry here. For the 2001 DB8, for the summary, we see the summary, not the default summary, but we're seeing the summary for the : /63 to null 0 in order to protect us against traffic coming here for a network that we don't actually have configured. So again, we pull the redistribute out, and then everything went away. And the summary on the interface doesn't seem to be doing what it should be doing, right? So when we were using IPv4, this worked and it wasn't a problem. It looks like with IPv6 that it's not going to function the same way. So we'll come back over here to HQ and say redistribute static, because they called for a static route. And then we'll get an interface Ethernet 0.1 and say no, IPv6 summary address EIGRP99, and it's going to force me to go all the way out to : /0. All right, so we'll pull that off. We get that graceful resync. And now back over here on branch 1, and that's not what we're looking for. There we go. All right, so now we see that additional information again, right, when we pulled that summary off. Okay, so there's 2 ways that you could do it, and I'm not sure if this is doing behaving like this because something's up, or maybe I have something wrong in there. But you can easily, in IPv4, this works without a problem, where you simply do the summary to quad zeros, right? All right, so this is going to wrap up challenge activity number 3 on configuring EIGRP for IPv6. Thanks so much for watching. Have a great weekend, and I will see you guys on Monday night.